KVL KCL based problem. Today I will focus on KVL KCL related based problem. Okay. So first of all, everyone try what about IT? Okay. First of all, try everyone what about IT, and after that I will focus on how can do. Okay. So first of all, everyone try what about IT? IT current. Okay. Everyone try. Hello everyone. Today we'll focus on KVL KCL based problem. Okay. So for beginner. So we have taken one problem. What about IT? Okay. That branch current is 10 milliampere. That is 40 milliampere, and that is 20 milliampere. What about IT? Okay. Whatever be the resistance here. Resistance is not given. So see very carefully. If anyone phased out, then tell me. Sir, I phased out corresponding to that problem. Then I will discuss again. Okay. If anyone face problem, then tell me. I will discuss again. Okay. So first of all, everyone focus. What about IT? I think sound is clear. Okay. Wait, I will check. Looking properly or not? Okay. Look properly or not? I think sound is clear. Sound is clear or not? Now, so we are focused on question number, whatever be the question. So I hope so. Everyone try. What about IT? Simply here KCL. What about KCL? First of all, I know that according to KCL, here I1, here I2, whatever be the node, here I5, here I4, given like that one. According to KCL say algebraic sum of current at any node. That one is called node. That one is called node. Node means for number of branches are attached. Okay, number of more than two branches. That is called node. How many branches? Here 1, 2, 3, 4, 5. So 5 branches. So algebraic sum of current at any node, and this be equal to 1 to and this be equal to m. That is 0. Okay. Or another word, you can say that incoming current, if we suppose that there was a positive direction, here positive incoming current, and this one is incoming current. Okay. If these two are positive, incoming current means which current upcoming to node. So I4 plus I5. Okay. Now that current direction are opposite to that one. Okay. So minus I1 minus I2 minus I3. That is 0. Sum of these 5 current is equal to 0. Okay. So you can say that algebraic sum, or you can say that another word, incoming current. This is equal to sum of incoming current. This is the sum of incoming current. You can say that I4 plus I5, this is equal to how much? I1 plus I2 plus I3. If you see very carefully, I1, I2, I3 are outgoing current. These three are outgoing current, and these two are incoming current at that junction. So you can say that sum of incoming current is equal to sum of outgoing current. So you can say that one, another word. What is the meaning of that one? Sum of incoming current at any node, sum of coming current at any node is equal to sum of outgoing, sum of, or you can say that sum of outgoing current at that node, at that node, at that node. Okay, so if you consider that node is A, it means clear. So sum of incoming current at that node is equal to sum of incoming outgoing current that node. Okay, clear or not? What is the meaning of that? Okay, what is the meaning of KCL? Okay, anyone faced doubt, then tell me. I think wise is clear or not? Wise is clear or not? If anyone faced doubt corresponding to that statement, I will repeat. Otherwise I will go on the question. I am going on the question. Okay, so clear. Now this concept apply here. Okay, how can I apply? Now if you see that, suppose that node is A. So first of all, that A node and that one B node. Incoming current at that node. This one. But what about that current, that branch current? No, not given. So we have considered I1. Okay. So incoming current at A node is how much? 40 plus 20. Okay. So first of all, mention branch current. After that, apply KCL. Okay. So here apply KCL at node. This one is a node, more than 3 branches. Okay, sorry, more than 2 branches, that is called node. So node A, and after that apply KCL at B. Incoming current 40 plus 20, this will equal to I1. So I1 is how much? 60 milliampere. After that apply KCL at that node. Incoming current I1 and 10. Okay, so 10 plus I1, this will equal to how much? IT. So 10 plus 60, that is IT. So IT is written as 70 milliampere. Okay, this is the right answer. Make it. If anyone faced doubt corresponding to that question, then tell me. I will discuss again. Okay, I will discuss again. If anyone faced doubt. Okay, if anyone faced doubt corresponding to any statement, any step, then tell me. I will discuss again. I hope so. Here all doubt. So now we have taken another problem. Okay. Now next problem is here 3. Now next one, resistance given, only resistance are given, whatever be the resistance. Here plus minus, here that one is given. Okay, here I2 current, here 3 milliampere, here I1, here plus minus, that is how much? 12 milliampere, and that one is 4 milliampere. Okay, so what about I1 and I2? So what about I1 and I2? Okay, our motto, determine I1 and I2. Okay, what about that value? So first of all, everyone try, then I will do. Okay, first of all, everyone try, then I will do. Okay, if anyone faced doubt corresponding to any step, I hope so KCL is clear. So how can do? First of all, if you see very carefully, apply KCL. First of all, branch current in I1, I2, suppose that whatever branch current in this, suppose that I3. Okay. Now, first of all, in given circuit, what about branch current? So decide first of all branch current. After that, apply KCL, KVL, and after that decide node. Okay. That node and that node. Okay. Apply KCL. Apply KCL at node A and after that B. Incoming current at that node 12. Outgoing current I1 plus 4. So what about I1? I1 is how much? 8 milliampere. Apply KCL at that node. Incoming current I1. Outgoing current 3 plus I2. What about I1? I1 is 8 and that one is 3. So I2 is how much? 5 milliampere. Sorry, plus 5 milliampere. Okay. So finally I1 8 milliampere and I2 is how much? 5 milliampere. Okay. How can check? First of all, if I1 is how much? 8 milliampere, then 12 is equal to 4 plus 8. It's right. Okay. Now 8 is equal to 3 plus 5 is also right. So these two answer is correct answer. Okay. These two are correct answer. If anyone faced out, then tell me, I will explain again. Okay. I hope so your problem or doubt are clear. I hope so. All doubts are clear. That's why we have taken another problem. Now, a current source given like that one, two resistance parallel. Okay. Here 40 kilo ohm, here 120 kilo ohm, here 16 milliampere. Our motto determine I1 and what about I2? Okay. How can do? First of all, everyone try, then I will do. First of all, everyone try, then I will do. Okay. If anyone faced doubt, then tell me, I will explain again. I think visibility is very clear. No noise problem. If you have faced noise problem, then tell me, sir, I face the noise problem. Okay. Or you can some disturbance. So how can do? First of all, our motto. What is our motto? Our motto determine I1 and I2. Okay. How can determine I1 and I2? First of all, if you see very carefully, so suppose that there is a branch A. Okay. At that branch A, incoming current, no any incoming current. So I1 is incoming current, simple, only one. And outgoing current is 16 plus I2. That is equation number 1. 2 unknown, 1 equation. We can find? No. Okay. Our motto determine I1 and I2. If you see very carefully, here 2 unknown, I1 and I2 are unknown. So how can we determine I1 and I2? Another equation, if 2 unknown, then at least 2 equation. We want 2 equation, at least 2 equation. So how can do? So first of all, if you consider I1 is equal to 16 plus I2. If you see very carefully here, that one is considered B. Okay. After that, if this one redraw, that one 16 milliampere. Here B, here A. It means that point B. Okay, current direction A to B. So A to B. Clear? After that, make this one how much? 40 kilo ohm, and that one is how much? 120 kilo ohm. Okay. Direction B to A. B to A, I1. Okay. A to B, how much? I2. That is I2. We are focused on I1 and I2. So how can we determine I1 and I2? How can we determine I1 and I2? Okay. So first of all, if you see very carefully, our motto, B to A, B to A, I1, A to B, I2, A to B, I2, A to B, A to B, I2. So we are focused on that one. Okay. So how can we determine? If you see very carefully, another current division rule. If this one and this one opposite direction, then I1 is written as simply 16 into opposite resistance, that is 120, divided by sum of these two, that is 120 plus 40, that is 160. So 0 to 0 cancels, 16 to 16, that is 12 milliampere. After that, if that value put here, then we got I2. Otherwise, if you apply current division rule, also that current direction and that current direction are same. So that one is written minus 16 into 40 divided by how much? 160. So 16 to 16 cancel. So we got minus 4 milliampere. Okay. So I1, I2 is how much? That one is 12 milliampere. That is minus 4. Now, if you you can use that equation also. If put here, I1 is how much? 12. Then I2 is how much? 12 minus 16, that is minus 4 milliampere. So you can find out I2 with the help of that equation, or you can with the help of current division rule. First of all, make it, if you face any problem corresponding to that one, tell me in comment. I will explain again. Otherwise, if you feel okay, that's no problem. Okay? If you feel okay, then no problem. If anyone faced doubt, then tell me, I will explain again. Okay, first of all, make it and verify your answer. If you try, then first of all verify your answer. It's okay, then okay. Otherwise, make it. Otherwise, make it. Okay. Otherwise, make it. If anyone faced doubt, then tell me, sir, I faced doubt corresponding to that point, then I will explain again. Then I will explain again. Okay? Then I will explain again. Okay? I will explain again. Now, simply our motor determine I1 and I2. So first of all, we have considered that branch and that node branch A and that branch B. If apply KCL at node A or B, then we got incoming current, how much? Simple I1. Outgoing current 16 and I2. Here, so that is equation number 1. After that, redraw the circuit again. Redraw the circuit, that's A and B. Here B. Okay. A to B, 16 milliampere. Okay. And current B to A. B to A, that is I1. A to B. A to B, that is I2. After that, apply current division rule. What about I1? I1 is how much? 16 into 120 divided by sum of these two resistance, then we got 12 milliampere. After that, apply KCL. After that, apply here current division rule also. Otherwise, that value put here, then we got I2 is how much? Minus 4 milliampere. If you apply nodal analysis here in that branch, both current direction upward. If both current direction upward, then I2 is written minus of that 16 into that resistance divided by sum of these two resistance, when we got minus 4 milliampere. Okay, clear or not? If anyone faced doubt, then tell me, I will explain again. Okay, I hope so. Okay, thank you very much. So now take another problem. Also. Okay. Now take another problem also. That one is current source. Okay. A resistance given like that one. Another current source given like that one. Okay. That is 44 milliampere. And that is R, and current is Ix. And that one is 10 Ix. Ix. So what about Ix? Basically our motor determine Ix. So first of all, everyone try, then I will do. First of all, everyone try, then I will do. Okay? First of all, everyone try, then I will do. Okay? Now, if you see this one, that point is a incoming current 44 milliampere, outgoing current Ix plus 10 Ix. Then what about final Ix? Ix is simply 44 divided by 11, that is 4 milliampere. Okay, that is 4 milliampere. Okay, that is 4 milliampere. that is 4 milliampere. If anyone faced doubt, then tell me. Comment it, I will discuss again. I will discuss again. Okay? Now next question. That one is 1 ohm and that one is 3 kilo ohm. Sorry, 3 ohm. That is 1 ohm. That one is 1 ohm. Okay, another resistance connected here. That is how much? 10 ohm. And that is 1 ohm. And that one is 2 ohm. And here a resistance connected. What about that is 10 ohm? 8 ohm. Sorry. That is plus minus 12 volt. Okay. And here Ix. So what about Ix? So what about Ix? Everyone try. First of all, everyone try. Then I will do. Okay. What about Ix? What about Ix? What about Ix? What about Ix? Okay. First of all, everyone try. Then I will do. Okay. Also comment it. If you got the answer, comment it. Okay. If you face problem, then tell me, sir, I face the problem. I will not understand about what are you saying. Okay. Then I will explain again. Okay. But comment is very important. Your feedback is more important than for better explanation. Okay. Speed is right or wrong. Voice is clear or not. Visibility is clear or not. Okay. If any. Okay. So how can do it? First of all, how can do? You can this question you can do lot of method. Okay. But we have focus on simplest. We have focus on simplest method. Okay. First of all, if you see this one, and this one, simplest method. 2 plus 8, both are series. So combination of these two, that is how much? 10 ohm. After that, if you see very carefully, these two are parallel. So combination of these two, how much? That is 5 ohm. Okay. And after that, 5 ohm and 1 ohm are connected in series. That is how much? 6 ohm. Okay. Clear or not? That is 6 ohm. Now next target, if you redraw the circuit, 1 ohm and that one is 3 ohm. And what about that resistance? 6 ohm. Okay. Here Ix. And what about that one is 12 volt. Very clear. Now these two resistance in parallel, so combination of these two, 6 into 3 divided by 9. So 3 3s are, that is how much? 2 ohm. That is 2 ohm. Okay. And 2 ohm and 1 ohm in series. Okay. So what about current I? I is written as 12 divided by 3. that is 4 milliampere. So 4 ampere, not milli, because of all in ohm. So 4 ampere. Okay, that is I is 4 ampere, but our target is Ix. Now look, here I is 4 ampere. You can determine with the help of current division rule, or you can also determine that is 12 volt, and whatever 4 into 1, that is whatever voltage across 1 ohm resistance, that is 4 volt. Why? Because this is 4 milliampere, here 1 ohm. So 1 into 4, that is 4 volt. And here we have considered Vx. If apply KVL in this loop, then minus 12 plus 4 plus Vx, this is equal to 0. So Vx is how much? 8 volt. Okay. So what about Ix? Ix is how much? 8 divided by 3. 8 divided by 3 ampere is the right answer. Make it. If anyone phased out, then tell me. I will explain again. If anyone phased out in any line or any step, then tell me. I will explain again. Okay? If anyone phased out or any queries corresponding to that question, then tell me. I will explain again. That is 2.06. Good. Good. 2 point something. Say yes. 2 point. Right. You are right. Good. Thank you. 2.666. All right. Okay. Thank you. Now next problem. Now next problem. So I hope so. Clear? If anyone phased out, then tell me. I will explain again. Otherwise, I will. First of all, our motor defined Ix. So we have considered these two resistors are series. So combination of these two, how much? That is 10 ohm. After that, 10 ohm and 10 ohm are parallel. So combination of these two, how much? 5 ohm. 5 ohm and 1 ohm in series. So how much? 6 ohm. 6 ohm and 3 ohm. After that, read our circuit, there is 6 ohm. That is 3 ohm and that is 1 ohm. Combination of 6 and 3, that is how much? 2 ohm. So we got written 2 ohm. 2 ohm and 1 ohm in series. Okay, so I is 12 divided by 3. That is how much? 4 ampere. Very clear. After that, 1 into 4, that is 4 volt. Apply KVL in this loop. Then we got minus 12 plus 4 plus Vx, this is equal to 0. So we got Vx is how much? 8 ohm, 8 volt. And what about Ix? Ix is 8 voltage. We got 8 divided by 3. That is how much? 8 by 3 ampere. Otherwise, you can also use here current division rule also. If you want to use current division rule, then how can do? Okay, so first of all, what about I? I is 4 milliampere. If you determine Ix, simply 4 into here 4 ampere. Our motor determine that current, both current direction opposite, so that's why I written positive. Positive 4 into, that is 6 divided by 3 plus 6, that is how much? 9. Okay, then how much? 3 to the 6 and divided by 3, that is how much? 8 by 3 ampere. Right answer. Okay, so you can use that method also at that step. Okay, so now we have taken another problem. If anyone phased out, then tell me. Sir, I will not understand about that point. That's okay. So now we have taken another problem. That current source, like that one. Okay. A resistance connected in parallel, that is how much? 2 ohm, and that is 2 ampere. Okay. Here 4 ampere. After that, 1 ohm and here 3 ohm connected, 3 ohm and here 1 ohm, and what about voltage? V naught. Our motto, determine V naught. Okay, so first of all everyone try, then I will do. First of all everyone try, then I will do. Okay, first of all everyone try, then I will do. Okay, first of all everyone try. Oh, sorry. You can someone say, kindly go over again, especially the second solution. Oh, actually I removed. So don't worry. I will discuss that type of problem. I will take another. So first I'll focus in that one. Determine V naught. Okay. Now, simple. If you see very carefully, that one is A, so that is also A. That one is B, that is also B. If you look here, 2 ampere and that one is 4 milliampere. Sorry, 4 ampere. Both are in opposite direction. Okay. So if anyone, both are opposite direction and also parallel connected, so you can say that is how much 2 ampere here, and that one is 4 ampere here. Sorry, silly mistake. That one is how much? 4 ampere. Okay, and that one is 2 ohm, and here 1 ohm, and that one is 3 ohm. 1 ohm and here 3 ohm, and that is V naught. Okay. So basically, if you determine what about I1, if you apply KCL at that point is A and that point is B. Okay, apply KCL at that point. Incoming current how much? Only 4 ampere. Outgoing current 2, and I1 is equal to 0. So I1 basically 2 ampere. Okay, I1 is basically 2 ampere. So you can say that if these two are removed and connect here, simply 2 ampere source. Basically we have that one is 2 ampere, and here 2 ohm, and that one is 1 ohm, and that one is how much? 3 ohm. What about voltage? V naught, and here 1 ohm. Okay, we have considered that is I naught. So how can do I naught? How can do I naught? I naught is, if you determine I naught, how can you determine? 2 into 2 divided by 2 plus, if you apply here node here basically we here apply current division rule. Here apply current division rule. If this is 2 ampere and here I naught, if both current direction opposite, that one is upward and that one is downward, so here written positive 2 ampere into 2 divided by that branch resistance and that branch resistance, sum of these two branch resistance, that is 2, and both are series, so 4 and plus 2, that is how much? 6 in denominator. So we got 4 divided by 6, that is how much? 2 by 3 ampere. 2 by 3 ampere, that is I naught. But our target is how much? V naught. So V naught basically how much? V naught basically, that is I naught, 3 into I naught. So 3 into I naught. If 3 into I naught is how much? 2 by 3. So that is 2 volt is the right answer. If anyone faced doubt, then tell me, I will explain again. So I hope so clear your Samuel, your doubt is clear or not? How can apply current division rule? How can apply current division rule? If anyone faces doubt in any step, then tell me, I will explain again. I will explain again. Okay? You can do this question lot of method, but who is the best method? Or you can say what is the best approach? No more calculation, simple circuit reduction. Circuit reduction. Common sense. We are all question do with the help of common sense. Okay? If anyone faced doubt regarding to any if anyone faced doubt regarding to 5.6, 5.9, which one? 5, no, 2 by 3, only 2 by 3. That is 2 volt. V naught is 2 volt. Our motor determine V naught. Thank you, thank you. Live is very helpful. Thank you. Okay, don't worry. I think you are, you feel comfortable. Okay. If you need any class, any related topic, then comment it. I want to that topic. I want to that topic. I feel very difficult. Then please take that topic in live session. Then I will design that lecture. Okay. So I hope so. That question is due, everyone. So okay. Thank you. Thank you. So I will take another problem also. Now next problem, I think it's okay. So we have taken another problem. That one is, sorry. That is 1 kilo ohm, that is 3 kilo ohm, and here a current source represent like that one, and that one is 2 kilo ohm, and another resistance like that one, and here 6 kilo ohm. After that another resistance connected here, that is how much? Okay, current direction here like that one, that is 3 kilo ohm, that is 1 kilo ohm, and that is 2 kilo ohm, and that is 24 milliampere, and that is 6 kilo ohm, and that is 6 kilo ohm. Our motor determine that voltage V naught, and that one is 12 kilo ohm. Okay, so first of all, everyone try determine V naught. After that I will do. Everyone can try. Okay. First of all, everyone can try. After that I will do. Okay, don't worry. Everyone can try. I think visibility is very clear. Voice is clear or not? If voice is clear, then it's okay. Otherwise, my side has no problem, I think. Okay. So, how can you determine V naught? Sorry. How can do? If you see very carefully, that one consider A. Sorry. We have another color. Otherwise, most of the students confused. If this one is A, that is also A. Why? Because no any source connected in between these two terminals. That's why. If this one is a B, so simple B, and that one is C. Okay. After that, if you see very carefully, A to B, Otherwise, you can redraw. If you feel if you're not comfortable with that one, so you can redraw. A to C, how much? That is how much? 24 milliampere. First of all, that is A point, and that is C point. Simply A to C represent also here. Okay, A to C, A to C, A to C. 3, 1, both in, sorry, both in series. So how much? Combination of these two, that is how much? 4 kilo ohm. Clear or not? Both are series. And these two are in parallel. 12 into 6 divided by 18, 3, that is 4 kilo ohm. So basically A to B, how much? 4 kilo ohm. Okay, and that one is 2 kilo ohm, and that one is 4 kilo ohm, that one is 4 kilo ohm, and what about that resistance? That is 6 kilo ohm, and our motto determine V naught. So it's clear or not? If anyone faced doubt or any confusion regarding to that circuit, then tell me. Actually, basically we redraw. Here, redraw that circuit, A and B. That is A and that is B. Okay, 2 and 4, 2 and 6 in series, and combination of these two in parallel. So that's why written 4 kilo. Now, if you look here very carefully, here R1 is 4. If you compare, if you apply, and what about R2? R2 is 2 plus 6 plus 4. That is how much? 12. Wait. 4 plus 2 plus, okay, that is 12. 12 kilo. If you apply here current division rule, then here R1, here R2, if you determine I2 current and here IS. So what about I2? I2 basically written IS into, if both current direction opposite, so that's why positive. If you apply current division rule, IS into R1 divided by R1 plus R2. What about IS? IS is 24. And what about R1? 4 divided by sum of these two, 16, 12, 4 plus 12, that is 16. Okay, 4 4 ja 16, 4 6 ja 24, that is 6 milliampere. Because why? Because resistance is kilo ohm and voltage in volt, that's why, that is 6 milliampere. After that, our target is V naught. So what about I2? I2 is how much? 6 milliampere. Here I2. Okay, that current also going in this resistor. So V naught is how much? 6 into I2. So 6 into 6. That is how much? 36 volt. That is 36 volt is the right answer. So V naught is how much? 36 volt. If anyone faced out, then tell me. I will explain again. Otherwise, I will explain again. If anyone faced out regarding to any step, then tell me. Okay? Without any hesitation. Without any hesitation. If you're not comfortable with, okay? If you're not comfortable with any step, then tell me. If you feel more difficult, so you can need more explanation, then tell me. Okay? If you want to more explanation, then tell me. I will explain again. If anyone faced out regarding to any step, then tell me. I will explain again. Okay? If anyone faced out regarding to any step, Method is very useful, very helpful. Method is very helpful or not? Give me feedback. Your feedback is very most important from my side. That's why I'm saying its class is okay, or good, or very good, or worst. Written very frequently, okay? Because your feedback is very important. Boost my energy. If you give me feedback, then I feel good. Okay? So I hope so, no problem. Then I will explain again and after that move on other question. Okay? Now, first of all, our more target is V naught. So that's why we have considered that node A and that node B. If this was A, that's also A, and that node C. Okay, after that, A to B 6 kilo ohm, A to B other 12 kilo ohm, both are in parallel. So combination of these two, how much? 4 kilo ohm. That is how much? 4 kilo ohm. Okay, clear or not? So A to B, connect here. A to C, like that one, and these two in series, that is 4 kilo ohm. So connect here. A to C. Okay. After that, A to B, combination of these two, how much? 4 kilo ohm combination, both are parallel, that's why 4 kilo ohm connected here. And this one, these two in series, so right, correct like that one. After that, if you see very carefully, this one is R2 and that is R1. R2 is how much? 2 plus 6 plus 4. So that is how much? 12 kilo ohm. So simply apply this circuit look like current division rule type. So you can apply here current division rule. I2 is Is into R1 divided by, because of these two current direction opposite. So that's why I2 is written Is into R1 divided by R1 plus R2. And put the value, we got I2 is how much? 6 milliampere. And what about V0? V0 is equal to 6 into I2. That current I2 to 6 into I2. So how much? That is 36 volt is the right answer. If anyone faced doubt, then tell me, I will explain again. Okay, I hope so. Our doubt is clear. Now, next problem. So first of all, make it after that. Now, next problem is here 3 kilo ohm, that one is 6 kilo ohm, a voltage source, and here that is 6 kilo ohm minus plus, that is 12 volt, and that one is 6 kilo ohm, and that one is 6 kilo ohm, and that one is how much? That is 4 kilo ohm, and that one is 12 kilo ohm. Okay. Now after that, that one is 3 kilo ohm, and that one is 6 kilo ohm. That is 6 kilo ohm. That is 3 kilo ohm. Okay. Our target is determine I naught. So what about I naught? Okay. What about I naught? First of all, everyone try, then I will do. First of all, everyone try, then I will do. Okay. There is a separate lesson on short circuit calculation. Okay, dear. I will take. Okay. So first of all, focus on that question. Our motto determine I naught. Our motto determine I naught. So how can we determine I naught? If you see very carefully, how can do? Now look, these two in series. So how much? 9 kilo. Simply written 9 kilo. Okay. 9 kilo ohm is parallel to that one, that is 12, and here 6. Okay. If you apply source transformation here, I know that source transformation I have already discussed. If voltage source given like that one plus minus, a resistance given like that one R, and here V, and that is X, and here Y terminal, then you can convert a current source direction, current, whatever current, V by R, that is V by R, that is I, direction of current decided by polarity of the voltage. Current always leave from positive terminal, so positive, so it means direction is upward, and that one is resistance connected right, R, and here X, and here Y terminal. Vice versa, if current I and resistance given like that one, then what about V? V is equal to I into R. And what about polarity? Current current from leave from positive terminal, so upper plate positive, lower plate negative. Upper plate positive, lower plate negative. Okay? So using that method here, how can apply? If you see very carefully, we are that method using that one. That is 12 volt, but polarity minus, here plus. So here minus plus, it means what about current direction? If this one is converted into current source, it means basically that one is given minus, here plus, and that is 6 kilo ohm, whatever, 6 kilo ohm, and that is 12 volt. Whatever with the, here suppose that X, and here Y terminal. If this one is converted into volt current source, then how can we convert? First of all, current is written 12 divided by 6, that is how much? 2 milliampere, that is 2 milliampere. What about current direction? Polarity, decided by polarity, here positive, here negative. Lower plate positive, upper plate negative. It means current direction downward. So current direction downward. After that, what about resistance? Simply 6 kilo ohm connected in parallel, corresponding to XY terminal. Clear or not? If anyone faced out, then tell me, sir, I do not understand about current division rule or voltage division rule. Sorry, source transformation. Basically, that one is a source transformation. Voltage source converted to current source like that one, or current source given then converted into voltage source like that one. So how can I apply? Clear or not? If anyone faced out, then tell me, sir, I faced the doubt corresponding to that point. How can I explain? Otherwise, I will remove that circuit. Okay. So this one remove from that circuit. Okay. So that one remove, that one remove, that one remove. If is okay, then okay. Now that is 9 kilo. If you redraw circuit, that is how much? 9 kilo ohm. That is 9 kilo ohm. After that, if that one make here, that is 6 kilo ohm. You can exchange. This one is current here. Both are parallel, that's why. And here, what about current source? That is how much? 2 milliampere, corresponding to XY terminal. After that, these two, if you see very carefully, these two in series. So how much? 16 kilo ohm. After that, that is 3 kilo ohm, and that is 6 kilo ohm, and that current is I naught. Okay. After that, if you see very carefully, these two in parallel, so 9 into 6 divided by 15. That is 15 by 5. If you see very carefully, 6 into 9 divided by 15. Both are parallel, that's why how much? 18 by 5. That is 18 by 5. It means, what is the meaning of that one? 3.6 ohms, kilo ohm. So combination of these two, basically we got how much? 3.6 kilo ohm. Okay. So that one remove. Okay. So 3.6 kilo ohm and 2 milliampere. That resistance and 2 milliampere are parallel. So if you convert into voltage source, then how much current leave from current going on downward direction? It means that was positive, here negative. 2 into 3.6, that is how much? 7.2 volt. Okay. And what about resistance? That's 3.6 kilo ohm. After that, that one is 16 kilo ohm, and that one is how much? 6 kilo ohm, and that is 3 kilo ohm. Okay, and here I not. Okay, these two are in series. So combination of these two, first of all recheck again. That is 6 plus 3, 9, and 9 into 6 divided by 15, then we got 3.6 kilo ohm. Okay, both are parallel, so it's right. After that, 2 into this. Okay, and that's it. Both are adding, then we got how much? If anyone faced out, then tell me. Okay, now 3.6 and 16, that is how much? 19 point. So that one minus, here plus. After that, 3.6 and 16, that is 19.6. Okay, and that one is 6 kilo ohm, and here 3 kilo ohm. Okay, here what about I naught? Okay, if anyone faced out, then tell me, I will explain again. Okay, so 3, 6. Now after that, and what about that is 7.2 volt. Okay, 7.2 volt. Now if you recheck, or you can say that if this one converted to current source, then what about current? That is 7.2 divided by 19.6. That is how much? With the help of calci, you cannot do easily with the help of calci. Okay, with the help of calculator, Seven point two divided by how much? 19.6. That is how much? We got 0.367. We got 0.367. 0.367 current direction downward because of polarity is here, lower plate positive and upper plate negative. That's why. And what about resistance? That is 19.6 whatever kilo, and that one is milliampere. Okay. After that, these two resistance in parallel, that is written 6 kilo ohm, and that is 3 kilo ohm, and our target is I naught. Okay, so if you remove that one and that one also, so if you see very carefully, these two in parallel. Parallel combination 19.6 into 6 divided by how much? 25.6. Then what about that value? 19.6 into 6. That is how much? 117.6 divided by 25.6. That is how much? Wait. 19.6. 196 into 6. That is how much? Okay. Divided by 25. That is how much? 4.5. 4.593. Okay. So you can make here, that is 0.367 milliampere direction, and that one is 4.593, and that one is 3 kilo ohm. Okay, and here I naught. If you see very carefully, apply current division rule, then we got minus, because both current direction downwards, that's why minus written. 0.367 into 4.593 divided by sum of these two, that is 4 plus 3, 8.593. Okay, what about that value? What about that value? That is, first of all, 0.3 using calci, 0.367 into 4.593, okay, like that one, divided by 8.593. That is how much? We got minus 0.196 milliampere is the right answer. Make it. Maybe mistake my side also in mathematics point of view. Otherwise, step is okay. Circuit reduction method. Maybe mistake. First of all, try. If anyone fails, we got minus 0. If anyone faced doubt, then okay. If anyone faced doubt, then tell me. Comment it. Okay. Sorry. 4 plus 3, that's 5. 4 plus 3, that's 7. Sorry, 7. 7. So, we'll check again. Okay. 0.367 into 4.593. So 1.685 divided by 7.593. That is how much? Yes, that is the right answer. Finally, we got right answer, minus 0.22 One silly mistake, your answer is going on wrong direction. Okay? Sometimes calculation mistake. Otherwise, okay, method is okay, then you can do. Okay. So I hope so. Your all doubt clear corresponding to KVL KCL. And how can apply source transformation for complex circuit. Okay. If any doubt, then tell me. So I face doubt corresponding to that step, then I will explain. Otherwise, if you face any doubt, then come and send me in WhatsApp number 9+991 for international student 9041398104. Okay, WhatsApp me. I will definitely I will do in next session. Okay, so tomorrow I will take another session at same time. So if any suggestion, then comment it, sir. You can do, or otherwise today class is over. Thank you very much. If you want more explanation regarding to any, then tell me. Okay.